System of forces. Learning objectives. At the end of this topic, you will be able to define force, list the characteristics of force, explain the composition and resolution of forces, discuss the parallelogram's law of forces, define the couple moment, and explain its resultant. Let us discuss the basic concepts of the system of forces. Initially, we can start with force. To deal with any problem in engineering mechanics, the concept of force has to be understood. A force can be a simple push we exert on a body. It can be a gravitational attraction between planets and the sun, or the force of magnetic attraction, or a wind pressure. Each of these forces has relevance to one or the other applications in various engineering disciplines, and hence the concept of force forms a basic in engineering mechanics. Force is defined as any action that tends to change the state of rest or motion of a body to which it is applied. The characteristics of a force are magnitude, the point of application on the body, the direction or sense in which the force acts, line of action. Let us understand the characteristics through a simple sketch. On the body, force AB is acting. The magnitude of 1 kilonewton is represented by the length AB. The arrowhead on the straight line indicates the direction of force. Either the head or the tail is used to indicate the point of application of force. Now, let us understand what is a system of force. In any practical application, we will come across a body or a system subjected to a single force. It is always associated with various constraints like the reaction from the supports, tension from the strings, or the gravity force, which is the weight of the body. When several forces of various magnitude and direction act on a body, they are said to form a system of forces. If these forces with their line of action lie in the same plane, they are coplanar, and if these forces further pass through a single point, they are said to be a concurrent coplanar system of forces. Visual shows the ball and socket being subjected to three forces which are concurrent and also lying in the same plane. The three forces are Fx, Fy, and Fz. Composition and resolution of forces. The term defined to reduce the given system of forces to a simple force which will be its equivalent is called the problem of composition of forces, and the term defined to replace a single force by several components which will be equivalent in action to the given force is called the problem of the resolution of forces. In the visual, you can see the two forces represented by vectors AB and AC, which can be reduced to a single force AD, and similarly the single resultant AD can be resolved into its components AB and AC with the help of the parallelogram law. Parallelogram of forces. Here we are going to discuss the reduction of two concurrent forces to its simplest equivalent using the law of parallelogram of forces. What does the parallelogram law say? When two forces acting at an angle are applied to a body at a point, as per the law of parallelogram of forces, their action is equivalent to the action of one force represented by the diagonal of the parallelogram which passes through the point of intersection. The diagonal is also called the resultant. Extension of the law. By successive application of the law, any number of concurrent forces can be reduced to a single equivalent. If two given forces P and Q acting at an angle applied to the body at A, then the magnitude of the resultant is. Suppose the angle alpha becomes too narrow and comes to 0, what will happen? Then the resultant will be the sum of the two acting in the same direction of the two forces, that is R is equivalent to sum of P and Q. This can also be verified by substituting for alpha equal to 0 in the equation. Similarly, you can find out what will happen if the angle is widened to 180 degrees. When the angle is widened, the two forces P and Q will act in the opposite direction, and the resultant will become R is equivalent to the difference of P and Q. The direction of the resultant will be in the direction of the force, which has a larger magnitude. What do you infer from this? The resultant of two collinear forces is equal to the algebraic sum of the two forces. What is collinear? Collinear means the forces acting in the same line of action and meeting at one point. Let us discuss the couple and its resultant of force system. A couple is defined as two parallel forces that have the same magnitude but in opposite directions and are separated by a perpendicular distance d. Figure 1. Since the resultant force is zero, the only effect of a couple is to produce a rotation or tendency of rotation in a specified direction. For example, imagine that you are driving a car with both hands on the steering wheel and you're making a turn. One hand will push up on the wheel while the other hand pulls down, which causes the steering wheel to rotate. The moment produced by a couple is called a couple moment. We can determine its value by finding the sum of the moments of both couple forces about any arbitrary point. For example, in figure 2, position vectors RA and RB are directed from point O to points A and B lying on the line of action of minus F and F. The couple moment determined about O is therefore. This result indicates that a couple moment is a free vector, that is, it can act at any point since M depends only upon the position vector R directed between the forces and not the position vectors RA and RB directed from the arbitrary point O to the forces. This concept is unlike the moment of a force, which requires a definite point or axis about which moments are determined. Scalar formulation. The moment of a couple, M, as shown in figure, is defined as having a magnitude of M is equal to Fd, where F is the magnitude of one of the forces and d is the perpendicular distance or moment arm between the forces. The direction and sense of the couple moments are determined by the right-hand rule, where the thumb indicates this direction when the fingers are curled with the sense of rotation caused by the couple forces. In all cases, M will act perpendicular to the plane containing these forces. Moment of a couple. When a force is applied to a body, it will produce a tendency for the body to rotate about a point that is not on the line of action of the force. This tendency to rotate is sometimes called a torque, but most often it is called the moment of a force or simply the moment. For example, consider a wrench used to unscrew the bolt in figure 1. If a force is applied to the handle of the wrench, it will tend to turn the bolt about point O or the z-axis. The magnitude of the moment is directly proportional to the magnitude of F and the perpendicular distance or moment arm d. The larger the force or the longer the moment arm, the greater the moment or turning effect. Note that if the force F is applied at an angle as shown in the figure 2, then it will be more difficult to turn the bolt since the moment arm will be smaller than d. If F is applied along the wrench as shown in the figure 3, its moment arm will be 0 since the line of action of F will intersect point O, the z-axis. As a result, the moment of F about 0 is also 0 and no turning can occur. We can generalize the above discussion and consider the force F and point O which lie in the shaded plane as shown in figure 4. The moment MO about point O or about an axis passing through O and perpendicular to the plane is a vector quantity since it has a specified magnitude and direction. The magnitude of MO is given by MO is equal to Fd, where d is the moment arm or perpendicular distance from the axis at point O to the line of action of the force. Units of moment magnitude consist of force times distance Example, Newton meter. The direction of MO is defined by its moment axis, which is perpendicular to the plane that contains a force F and its moment arm D. The right-hand rule is used to establish the sense of direction of MO. According to this rule, the natural curl of the fingers of the right hand as they are drawn towards the palm represent the tendency for rotation caused by the moment. As this action is performed, the thumb of the right hand will give the directional sense of MO as shown in figure 4. Notice that the moment vector is represented three-dimensionally by a curl around an arrow. In 2 dimensions, this vector is represented only by the curl as in figure 5. Since in this case the moment will tend to cause a counterclockwise rotation, the moment vector is actually directed out of the page.